Okay, so we've got the guess of kangaroos, rhesus monkeys, humans, and turtles. So here is our little snapping turtle laying her eggs. And have you touched an egg? Any egg ever? Outside of an egg. Chicken egg in your fridge. Describe it. Hard. Okay. That hard outer shell keeps the moisture in and keeps the little not yet a chicken from drying out. And inside that shell, there's the membrane. Oh, yeah, there's that membrane. Guess what that is? Amnion. It's the amnion. So when we look at this turtle laying her eggs, now her eggs are soft. They are not hard. They're leathery. But inside them, guess what we still find? We find an amniotic sac. And as a matter of fact, there's a little reptile egg. This could be a snake or a turtle or anything else. And there's the yolk sac. And right there, what's that structure? It's an amnion. So in fact, turtles do have an amnion. Now, did you guys all just discount the lamprey?
Yeah.
Okay, why? What about the fish? Why? So what does the amnion do?
Wait.
Keeps the egg moist, right? Fish lays eggs. What about frogs? They lay eggs. Well, let's look up some frog eggs. Did I take a picture? Darn it. No, I did not. So the purpose of the amnion is to keep the not yet whatever wet. Keep it from drying out. Where do frogs lay their eggs? In the water. Why do you think they lay them in the water and not on land? Because it doesn't have an amnion. If they were laid on land, they would dry out. Okay. So that shell, that amnion, and then further on top of that, a shell, actually is an evolutionary step. It allows you to lay your eggs outside of water. Guess where lamprey, those vicious, nasty, toothy-looking aquatic creatures, fish lay their eggs in the water too. No amnion. So, no amnion in tuna, no amnion in bullfrogs, no amnion in lamprey. Okay. So now, mammary glands. What are they?
Productive glands, sweat glands.
Nope. Mammary glands, mammals. What differentiates mammals? Milk. Milk. You can milk a mammal. If it's a mammal, you can milk it. Bat milk cheese, anyone? They're teeny, though. Little teeny, tiny nipples. Very hard to milk a bat. Plus, there's that whole hanging upside down thing. The milk it's a mess. You could milk a cat. You could milk a dog. You could milk a sheep. You could milk a goat. You could milk a cow. You could milk a raccoon. Ew, raccoon milk cheese. Well, is a fish a mammal? No.
Well, not milk, but eggs.
Yeah, but that's not milk. We're talking about mammary glands here. We're talking about mammary glands, which are glands which produce milk. So, huh? I love cheese. If it's a mammal, you can milk it and you can make cheese. Raccoon cheese.
I don't like Swiss cheese.
Oh. I love all kinds of cheese. I haven't met a cheese I don't like. So, who here produces milk?
Mammals.
Give me one. Kangaroos? Okay. So kangaroos are a mammal, you're saying?
Yep.
I would agree. What else? Monkeys. Rhesus monkeys produce milk. What else? Humans. What else? Oh, that's it. There is no frog milk. There is no turtle milk. No tuna milk. No lamprey milk for sure. Now, the placenta. Oh, what's a placenta?
It's like what comes out, like when the baby comes out, it like comes out with the baby.
After the baby, yes. It comes out after the baby or the calf or the lamb or whatever. And the placenta, so this is a baby in utero. And this big, juicy, meaty thing right there is the placenta. It looks like a big, fat chunk of steak. I love the faces. So in that big, fat chunk of steak, there's a bunch of blood vessels, and there are a bunch of blood vessels on the side, on the uterus, that all connect to this big fat telephone cord looking thing that connects to the baby, the umbilical cord. And on the other side, exactly, are all these blood vessels that connect to the mother's uterus. And so this is what allows the exchange of nutrients and oxygen, is the placenta. It's pretty revolutionary. It's pretty cool. So we talk about placental mammals. So first of all, you have to have an amniotic sac to have a placenta because it connects the amniotic sac to the uterus. So anything that doesn't have an amniotic sac is automatically out. So what do you think has a placenta? Well, obviously, I just showed you a picture of a human placenta. What else do you think has a placenta? Monkeys, that's a good guess. So the real question then is, what about kangaroos? So humans, dogs, cats, raccoons, cows, sheep, pigs, all placental mammals. They have a placenta. Kangaroos are a mammal.
Wait, so does the placenta regrow?
Every time that there's a new pregnancy, the uterus forms a new placenta. It grows this big chunk of meat, this big hunk of muscle with all these blood vessels. And it's a lot of work. It's totally a superpower. Like, your mothers all grew a placenta from scratch. Holy cow. Approximately half of you at some point in your lives would have the ability, if you so choose, to grow a placenta from scratch. How cool is that? It's totally a superpower. Okay, so the kangaroo does not have a placenta because it's a marsupial mammal. Possums don't have a placenta. Koala bears don't have a placenta. The marsupial mammals are a whole separate evolutionary line. They don't have a placenta, so their babies are born about halfway cooked, so to speak. And then what do they do in that pouch? They nurse. They grab onto a teat and they just nurse for the rest of their development. So it's as if a pregnant woman gave birth at 20 weeks instead of 40 weeks, because that's 40 weeks is the duration of a human pregnancy. At 20 weeks, the kid was kicked into a pocket and they just latched on and nursed for the next 20 weeks.
Wait, so how do you know if it's ready?
Well, at some point, they get a little big for the pocket. Though there are pictures of joeys who are clearly, I mean, if you've ever had animal, like I had barn cats, and I remember the kittens, they were no longer kittens. They were like 5 months old. And my God, if their mother stood still long enough, they would still try to nurse. I'm like, okay, you people have been eating solid food and catching mice for 2 months now. Let it go. And she would like hiss at them and spit at them and walk away because she couldn't lay down, but they'd go try to nurse. And there are pictures of joeys, really large joeys, which are baby kangaroos, who are not babies anymore. They're like teenage joeys, and they're like sticking their head down in Mama's pouch. You know, Mama's going, "Get out of here, kid, go! You know, go away, I'm done." So, I mean, at some point they no longer fit in the pouch, you know. And the event of going from being in the uterus to being in the pouch and nursing, I think, is probably as spontaneous as labor is in a placental mammal. Where, like, when the body says it's ready, it happens. You know, like it or not, it's happening. But once they're in that pouch, you know, as they get older, they'll stick their head out. So, okay, now let's talk about our last category. Canine teeth short. Everybody put your finger on your canine if your hands are clean enough. It's the pointy one. It's the pointy one. And I've got a couple little friends here who I brought along. My little friend. Now, this is one of my little friends. I mean, it's only got one canine left, but it's a pretty nice canine. Pretty nice, isn't it? It's also got this weird hole in the back of the skull. It's not a possum. And somebody, actually Lucian, just brought me this morning. This is another little friend. This one doesn't have any canines.
That's a deer.
It is a deer, but it's also got this hole in the back of the skull.
Where the spine connects to the brain.
That's where the spine connects to the brain, yeah. That's where the vertebral column and that big fat, what's that big cord that runs up the back of your body? Dorsal nerve cord. It's where the spinal cord enters the skull and connects to the brain. That's kind of important. That is kind of important. So, the next one is canine teeth short, foramen magnum forward. So that hole in the skull is called the foramen magnum. And did you notice where my little friend's foramen magnum is?
In the back.
In the back. Because this little organism's spinal column comes off the back of its skull. Where do you suppose yours is? In the bottom. Because your spine sits on top of your head, not out at the end of it. So let's look at a rhesus monkey, shall we? So there's a rhesus monkey. Would you say that those canines are shortened? I'd say those are pretty vicious looking canines. So I would definitely not say shortened canines, but then let's look at the skull. So this lineup does not include rhesus monkeys. This has got some chimps and bonobos. And these are early hominids. These are Australopithecus species. And you'll notice that in all of them, that hole is pretty well forward. So let's look at a rhesus monkey skull. Guess where that spine comes out? Back there. Foramen magnum in that species has not yet moved forward. So the only one of these species that has got both short canines and the hole in your head move forward are humans. So now what you're going to do is total up the number of X's that each species has. Oops. Okay, I guess something like that. What these are shared derived characteristics. So they're shared, meaning, well, every single one of these things has got a dorsal nerve cord. It's shared among all these species. Derived, meaning they inherited it from some common ancestor. So some common ancestor of all those species had a dorsal nerve cord. Some common ancestor of, what, 1, 2, 3, 4, 5. 5 of those species had paired appendages. So what we're going to do now is make a Venn diagram with this information. So I'm making a series of nested boxes, and in my outermost box, I'm going to write the first characteristic that is shared by every single species in this table. What is that? Dorsal nerve cord. I'm going to write it in a different color so it's clear. So dorsal nerve.
Wait, how many boxes?
How many characteristics do we have? 1, 2, 3, 4, 5, 6, 7. So you'll need 7 boxes. 1, 2, 3, 4, 5, 6. I'll need one more. Copy. Paste. There. Okay, so what I'm going to do is, so here's the thing. If you write something in a box, it's got that characteristic. Anything that's inside that outer line that says dorsal nerve cord has got a dorsal nerve cord. So as we go in, if it's in here, it's got all the things. So we're going to start off in that outer area by writing the only species that only has a dorsal nerve cord, which is the lamprey. I'll write this in some other color. Lamprey. Because lampreys have a dorsal nerve cord and nothing else. They don't share any of the other features here. So we've got paired legs, bullfrog. So our next characteristic is the amnion. And what species has dorsal nerve cord, paired appendages, paired legs, and an amnion, but nothing else on that list? Turtles. So where do we go after the amnion? What's the next thing to develop? Mammary glands. What? So what would have mammary glands, amnion, paired legs, paired appendages, and a dorsal nerve cord, but not a placenta or canines? Short canines? Kangaroos. meaning that some ancestor of the kangaroo had an amnion, had paired legs, had paired appendages, had a dorsal nerve cord. What's the next step? What's the next structure that we see develop? Placenta! Placenta, and who's got a placenta?
Monkey.
Yep, the Rhesus monkey. Okay, last characteristic to develop, short canines. Foramen magnum forward. And the only species that we're showing here that's got all of this is humans. There are a couple other species that would be in that same box with us. Bonobos and chimps would be there, but we don't have them on our Venn diagram. So what this is going to do is help you to construct a cladogram. And I will tell you this, the cladograms are very emphasized on the end of course exam. I think there was one year where there were like 12 cladogram questions. Yeah. Out of 30 questions. So like a third of the questions involved a cladogram. So I want to make sure that you are good with these because my job is to help you beat the test. Okay. So how do we do a cladogram? Well, we start off with a line. Just like that. And we're going to put little boxes, and I'm actually going to do that. There. We can just do that. Whoops. Okay. So each one of these boxes represents a shared derived characteristic. And what we're showing on this cladogram is sort of the order in which these things appear as organisms evolve. So the thing that's shared by the most organisms here is a dorsal nerve cord. So I'm going to label this black box dorsal nerve cord. And then any species that has a dorsal nerve cord but none of the other shared derived characteristics, I'm going to put here, and we all know what species we're talking about. The lamprey, that vicious toothy thing. So what's the next characteristic? Paired appendages. Are there any species that have paired appendages and dorsal nerve cord and not anything else? Huh? Tuna. So our next characteristic is the paired legs. Oops, I screwed that up. There. Species with paired legs, paired appendages, and a dorsal nerve cord, but nothing else is what? The bullfrog? Yep. And what's our next characteristic? Amnion. Oh, paired, no, amnion, yeah. And that would be what, our turtle? Is it a snapping turtle? Yeah. Okay, next characteristic. Mammary glands. So remember, you can't milk a turtle. And what's got, what is that? Kangaroo. After mammary glands, we see the development of a placenta. Then we see short, I'm just going to abbreviate this. Short canines, foremag, forward. Okay. Okay, so what has got a placenta, but it doesn't have the shortened canines? The Rhesus monkey. And then our last critter on here, of course, is us. So when you look at this, what we're saying, we can look at something below this line, below that box. And we're saying that it's got all of these characteristics, amnions and paired legs and paired appendages, but it has none of these. And these are really useful. We look at these to figure out common ancestors. So the point at which two species would have split off, somewhere back here there was a common ancestor. That's the split point. And that open circle represents the ancestor of both snapping turtles and kangaroos, rhesus monkeys, etc. So it's this, the circles on that line represent the common ancestors. Okay, what I have for you is a cladogram you're going to do on your own. And I apologize because I looked at the front side and I thought, oh, this one's really easy. I'll give them the easy one to do on their own. We'll do the complicated one together. And then I realized that when you look at both sides of it, this one's actually pretty tricky. But I'm going to have you get started now. What's been done for you is the initial chart with who's got what characteristics, who's sharing what structures. Everybody got one? Wunderbar. So the chart has been done for you. You're going to start from the Venn diagram. And if you want to total up the number of shared derived characteristics they've got, that's probably useful. A lot of people feel that writing in the total number of shared derived characteristics helps. And like I said, this one's got some twists. So get started, and then we will finish walking through it together tomorrow. But I do want you to get the Venn diagram done. I want you to at least try the Venn diagram and try the cladogram. While you are working on that, I'm going to come around, have the one that we did together out, because I'm going to give you 10 points for having completed it, even though we did every single step of it together. That's it.